today's lesson is on solving inequalities using multiplication and division. So to get started, let's get this key idea written down. This is multiplication and division property of inequality, case 1. There's going to be 2 cases we look at today. And in the first case, this is where we multiply or divide each side of the inequality by the same positive number, and that inequality remains true. So all of our first examples are going to involve multiplying or dividing by a positive number. So here we have x over 5 is less than or equal to negative 3. We want to get x by itself to solve this inequality. So we need to multiply both sides by 5, and we get x is less than or equal to negative 15. Now, I want to put negative 15 somewhere on my graph. I'll put it in the middle. We could count by 1s, we could count by 5s, we can count however we want. I think I'll count by 5s. I'll say this is negative 10. As we get larger, we're getting closer to 0. Negative 5, negative 20, negative 25. And here we know that negative 15 is a solution. That's part of the solution set, but also anything less than negative 15. So anything to the left of it on the number line. Now, to check our inequality, we're going to use any number that's part of the solution set. Because I counted by 5s, any of these numbers work just fine. If you counted by 1s, you might want to kind of think of something a little bit further down the number line that's easily divisible by 5, that's also part of the solution set. Keep in mind, though, you don't want to use the number that has the circle on it as your check, because that won't tell you whether you shaded in the right direction, right? Even if we shaded to the right, we would see that negative 15 is a solution. So we want to pick somewhere that the arrow is shading, not where the circle is. Okay, so I'm going to use negative 20. Negative 20, I'm using my original inequality. Negative 20 over 5 is less than or equal to negative 3. This simplifies to negative 4. Negative 4 is less than or equal to negative 3, and that is a true statement. So that tells me that negative 20 is part of my solution set, and therefore I have shaded this the correct direction. Let's look at another example. Here we have 6x is greater than negative 18. To get 6 by itself, I'm going to divide both sides of the inequality by 6, and I get x is greater than negative 3. I'll put negative 3 on my number line, kind of somewhere in the middle. This time, let's just count by 1. So I'm going to go negative 2, negative 1, then this direction, negative 4, negative 5. X is greater than negative 3, so negative 3 itself is not a solution. It's an open circle, but it's anything greater than negative 3. So this time I'm going to the right. Now, as I'm checking my solution, I can use any of these numbers. So I could use negative 2, I can use negative 1. For me personally, anytime 0 is part of the solution set, I tend to use 0 because I think it's easier. The computation works out nicely. So I'm going to do 6 times 0 is greater than negative 18. And that says 0 is greater than negative 18, which is true. So we are good. All right, here's one more key idea, and this is for case 2. This says that when you multiply or divide each side of the inequality by the same negative number, the direction of the inequality symbol must be reversed in order for the inequality to remain true. So we're going to look at some examples of this. So here we have our first inequality. Negative 3/2 x is less than or equal to 6. To get x by itself, we need to multiply by the reciprocal of negative 3/2, which is negative 2/3. And then just like equations, we'll do the same thing to this side of the inequality. Our 2 reciprocals cancel to 1, so we have x on the left side of the inequality. And on the right side, we have 6 times negative 2/3. That would be negative 4. But our property tells us we're not going to say x is less than or equal to negative 4. We're going to say x is greater than or equal to negative 4. We're going to check a solution to make sure that this is true. So we'll put negative 4 somewhere on our inequality line, our number line, I'm sorry. Negative 5, negative 6. All right, and then in this case, negative 4 is a solution, so that's a closed circle, and x is anything greater than that. So in this case, we're saying 0 is a solution, so I'm going to use 0 to check our answer. So I'm going to have negative 3/2 times 0 is less than or equal to 6. We have 0 is less than or equal to 6, which is true. So we have shaded the correct direction, but we had to reverse that inequality symbol. Let's try another example. Here we have negative 3z is greater than negative 4.5. Okay, so we're going to go ahead and divide both sides by negative 3. And we get z on the left side. And on the right side, we have positive 1.5. And then instead of using the greater than symbol, we're going to change it to the less than symbol because we divided by a negative number. So I want 1.5 somewhere on my number line. I'll just count by halves. 1.5 itself is not a solution, so it's an open circle, and z is anything less than that. So in this case, 0 will be a solution. It's way over here. So we can use 0 to check our solution to make sure we shaded the right direction. Negative 3 times 0 is greater than negative 4.5. Negative 3 times 0 is 0, and that is greater than negative 4.5. So we have shaded the right direction and solved this inequality. So go ahead and practice a few of these on your own, and I will see you soon.